Okay, so hi there again. We're going to continue with our videos in the mathematics in the modern world, and we're going to talk about the same module that is problem solving with patterns and puzzles. And we're going to talk more in particular about the Pascal's triangle. And we have seen the how the Pascal's triangle is constructed. We can see the patterns within it. One particular pattern that we will use that we can use in algebra, and we're going to talk about that in this video, is about binomial expansion. So one significant pattern found in the Pascal's triangle is the binomial expansion in the form of x plus y quantity raised to n, where n is the row or the nth row of the Pascal's triangle, and the values in that row are taken as the coefficients of that expanded form. So this is one topic in number theory, also in algebra, especially when you reach already the polynomial functions, and so that you can expound a binomial into raised to the nth degree. This is also one particular topic in the fundamentals of number theory. The proof of this is actually what we call the binomial theorem, but let's not talk about that further. I have one video about that if you want. I have a playlist for number theory, but anyways, we're going to use this Pascal triangle over here. So example number one, this is quite trivial. We have already seen this or already have used this. This is very basic algebra. This is x plus y raised to 2 or x plus y squared. So how can we make use of the Pascal's triangle here? So since our n, or the nth row, is 2, we're going to consider the second row of the Pascal's triangle. So remember, we have 1, 1, 1, and 1, 2, 1. We call this our row 0. This is our row number 1, and this is our row number 2. So since the degree is 2, so we're going to make use of row 2 in order for us to expand this. So, and these numbers in the Pascal's triangle will be taken as the coefficients of those terms. So we're going to write it as 1, 2, 1. And those are the coefficients. How about, sir, the terms, the variables within the term? For sure, we have x and y there. How can we um, put that in these put it together with these coefficients? So what we're going to do is we're going to first remember we have term 1 and term 2. We're going to make this we're going to start with term 1, with that is x, and we're going to put the degree there, which is 2. We're going to put that on the x. And then secondly, what we're going to do on the next term is we're going to deduct the x. It's going to go down by 1, and the y will increase by 1. And that will be the pattern from first term to the nth term, right? Again, that will be the pattern from the first term to the last term. So 2 minus 1 is 1, x 0 plus 1 is 1, plus x minus 1, again, we will deduct 1 here, and we will increase 1 here. This becomes 0, this becomes 2 or squared. So hence what we have as our final answer, we don't need to write the 1. This x raised to 0 is going to become 1, so our answer would be x squared plus 2xy. We don't need to write the exponents 1, plus this 1, x raised to 0 is also 1, so we're going to write this as y squared. And that will be our answer, as what we know already by, squaring a binomial. But how about if the degree is not on the not 2? So we know already how to square a binomial. How about if the degree is, like, for example, 5? So with this, we're going to consider the fifth row of the Pascal's triangle. So we're going to have here 1, 1, 1, row 1, row 2, row 3, row 4, and row 5. There. So how do we do this? Again, these serve as our coefficients. So 1, 5, 10, 10, 5, 1. So let's write it here. 1, 5, 10, 10, 5, 1. And let's start with again with the x. This x will be raised to 5. This y will be raised to 0. We will increase the x, or rather, we will decrease the x. Sorry about that. We will decrease the x, and we will increase the value of y. So that's going to be plus. This becomes x raised to 4 and y raised to 1. So we're going to decrease this and increase this. Next, we have x cubed y squared. So again, we're going to decrease this, increase this. What we have is x squared y cubed. If I decrease this, increase this, plus x raised to 1, y raised to the power of 4, plus, lastly, decrease this, increase this. What we have is x raised to 0, y raised to 5. Important thing to notice here is that the exponents, if we're going to add them up, it will always be equal to the degree, which is 5. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, and then so on. So let's kind of fix this. This will give us the answer. X raised to 5, y raised to 0 can be written as 1, plus 5x to the fourth y. We don't need to write the 1 on the exponent on the y, plus 10x cubed y squared, plus 10x squared, sorry, 10x squared y cubed, plus 5x, we don't need to write the 1 raised to 4, plus this becomes 1, right? So we have y raised to 5, and that's our answer. Okay, so x raised to 5 plus 4x fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth plus y raised to 5. And that's going to be the answer here. I'm going to delete those written symbols here, and then we can see that our answer is the same with the answer key right here. So as you can see, so we have 5x, rather x to the fifth plus 5x to the fourth, and then you can see it yourself. It's the same. How about this one? Say we are told to expand x plus y raised to 7. This is quite challenging itself. But let's have it. So we need the seventh row of the Pascal's triangle. So how will we do that? Let's continue this. So we have 1, 1, 1, 1, 2, 1, row 2. We have row 3 here, row 4, row 5, row 6, and row 7. Okay, so we need this sequence of numbers in order for us to get the coefficients. So these are the coefficients. Actually, these are the coefficients of that expanded form of x plus y raised to 7. So uh, let's have it. We have 1, and then 7, 21, 35, 35, 21, 7, and 1. Okay, so I think we can delete this now. We don't really need it. We already know the sequence. So next is we're going to work out the x and y, since the coefficients, the variables here are both x and y. So let's start with the x. raised to 7, y raised to 0. I think you know already what will happen. We have x raised to 6, y raised to 1 plus x raised to 5, y squared plus x to the 4th, y cubed plus x cubed y squared plus x squared. Sorry, this should be y to the 4th. My bad. X cubed y to the 4th. So this should be x squared y to the 5th plus x raised to 1 y raised to 6 plus x raised to 0 y raised to 7. You may wonder how I knew that I was wrong. If you try to add those two numbers, 3 plus 2, that's going to become 5. It's not equal to 7. Remember that all the sum of the exponents must be equal to the degree, which is 7. So notice right now that all the sums are 7. So let's kind of fix this, and we'll get the answer. This will be equal to, this becomes 1, right? So we have x raised to 7 plus 7x raised to 6y plus 21x raised to 5y squared plus 35x to the 4th y cubed plus 35x cubed y to the 4th plus 21x squared y to the 5th plus 7x raised to 6 plus this becomes 1, so we have y raised to 7. That will be our answer for example number 3. As you can see, our answer is the same here. So you try to look at it. Let me erase first. So what you can see here are is the corrected answer. So notice that it's the same as our answer, the one that we derived ourselves. So you can check it out. And pretty much you can say that it's the same. So that's it for our video in Pascal's triangle. Hopefully you can see how we use the Pascal's triangle in binomial expansion, and that is making use of the binomial theorem. In the next video, I'm going to show you maybe one or two examples of variations of this. Say, given in all our examples that the sign are always plus signs. So how about if minus signs? Let's take a look at that. How about if it's not x and y? How about if it is 3x or with minus 3 or 3x plus 4, for instance? So how do we expand the binomial? So I'm going to give a variation of this in the next video. So stay tuned and see you there. Okay, thank you very much for watching.